My name is Jianwei Huang, and I'm with the Network Communications and Economics Lab at the Chinese University of Hong Kong. Today we're going to talk about the research project of Wi-Fi data offloading. This line of research is really motivated by the very fast growth of global mobile data traffic. Cisco has been predicting that in the next few years, the annual growth rate of the global mobile data traffic will be roughly 66%. However, if you look at the past experiences of how the cellular mobile network capacity is growing, it's only being a rate of 36%. So there's a widening gap between the supply and demand in this mobile data market. The question is that how can we address this widening gap? There are many potential approaches. Today we're going to focus on one particular one, which is the Wi-Fi data offloading. The idea for Wi-Fi data offloading is simple. Instead of sending all the traffic through cellular base stations, we can encourage users to associate with the Wi-Fi access point so that deliver traffic through Wi-Fi. And this way, we can reduce the congestion on the cellular network and improve the users' quality of service. As an example, in the US, AT&T back in 2012 already deployed 32,000 Wi-Fi hotspots. These hotspots accumulate 2.7 billion Wi-Fi connections in 2012 alone. And 80% of these connections actually come from AT&T's own mobile customers. So these representing traffic that could have been delivered through cellular networks, but now they are delivered and offloaded through Wi-Fi networks. The reason operators are interested in Wi-Fi offloading is due to several reasons. One, we have already mentioned, offloading can relieve the congestion on the network and can improve the quality of service, hence can reduce the user churn in the long run. Furthermore, an innovative cellular operator will be able to deeply integrate cellular and Wi-Fi networks, can offer new additional services and attract new customers in this new network, and hence boost the overall network revenue. There are two types of data offloading we may consider. One is called user-initiated offloading. This is something that we are doing every day. We open our cell phone, look at a list of Wi-Fi access points, and choose one of them. Increasing popularly, there is another network-initiated offloading, where the mobile operator will make the offloading decision on behalf of the users by selecting the Wi-Fi access point that is cheapest or has the fastest connection speed. This can already be implemented through the new standards such as Hotspot 2.0. In our research, we look at both types of data offloading. We'll also look at two different perspectives. One is the microscopic perspective, by looking at the user's decision for offloading. And the other is a microscopic perspective, by looking at interactions between cellular operator and Wi-Fi operators. Next, we're going to use three projects to illustrate our research results. In the first project, we look at the case of delay optimal data offloading. In this case, there's a single mobile user that's moving across multiple locations. All these locations are covered by a single cellular base station. Some of these locations are covered by Wi-Fi access point. The user has a large file to transfer before a certain deadline. So based on his mobility, file size, and deadline, he needs to decide at each single time slot, should I use cellular network, or should I use Wi-Fi network if I can access them, or should I wait until I meet the future Wi-Fi access point to reduce my transmission cost. In a second example, we look at interaction between one cellular provider and multiple Wi-Fi providers. The cellular provider wants to use Wi-Fi for offloading purpose, but it needs to compensate Wi-Fi providers for their increased cost and reduced revenue. So we consider a bargaining framework where the operator talks with multiple Wi-Fi providers either through a sequential bargaining or concurrent bargaining. We'll look at which bargaining protocol and which sequence of bargaining will lead to the maximum performance and benefit for the cellular providers. In the third example, we look at the more interesting case where the multiple cellular providers are interacting with multiple Wi-Fi providers. In that case, we design an iterative double auction mechanism where the cellular providers and the Wi-Fi providers both act as bidders in this auction. They submit bids, and the system will iterate and eventually converge to a social optimal system state. More publications regarding mobile data offloading can be found at the Network Communications and Economics Lab website at the Chinese University of Hong Kong. Thank you.